Two tiny pieces of plastic. No wires, no buttons, no setup. You just take them out of the case, put them in your ears, and they are already connected, already playing, already perfectly in sync with each other. The first time most people used Airpods, they genuinely felt like magic. But here is what nobody tells you. The engineering inside those two tiny earbuds is so complex, so precise, and so difficult to manufacture that Apple spent years figuring out how to build them before a single pair ever reached a customer. So today, we are going inside the Airpods factory to find out exactly how the most popular wireless earbuds ever made go from raw materials to the little white case sitting in your pocket. Before anything gets built, Apple has to solve a problem that sounds simple but is actually one of the hardest challenges in consumer electronics manufacturing. How do you fit a complete wireless computer inside something small enough to sit comfortably inside a human ear? Because that is what an AirPod actually is. It is not a speaker with a Bluetooth chip glued to it. It is a fully functional computing device with its own processor, its own microphones, its own accelerometer, its own optical sensor, its own antenna system, and its own power management system, all packed into a space roughly the size of a large grate. And every single one of those components has to work perfectly together every time for every single user, regardless of the shape of their ears, the environment they are in, or what they are doing while wearing them. The outer shell of each AirPod is made from a hard thermoplastic that gets injection molded into its final shape. Injection molding sounds straightforward, but at the scale and precision Apple requires, it is anything but. Molten plastic gets injected into a steel mold under high pressure and then cooled in a controlled way to produce a shell with wall thicknesses that are consistent down to fractions of a millimeter. The reason wall thickness matters so much is that the acoustic chamber inside the AirPod, the space where sound is produced before it travels into your ear, is tuned to a specific volume. Change the wall thickness even slightly, and you change the volume of that chamber, and you change the sound. So Apple controls the molding process to tolerances that most plastic manufacturers would tell you are impossible to hold consistently across millions of units. Apple holds them anyway. Inside that shell, the first component to go in is the custom Apple H2 chip, and this chip deserves a moment because it is genuinely remarkable for something this small. The H2 chip handles Bluetooth connectivity, active noise cancellation processing, transparency mode processing, spatial audio rendering, and communication with the paired device, all simultaneously, drawing power measured in milliwatts. It processes audio in real time with a latency so low that your brain cannot detect any delay between the sound leaving your device and arriving in your ears. It also handles the adaptive EQ system, which analyzes the fit of the AirPod in your ear using the internal microphone and then adjusts the frequency response of the speaker in real time to compensate for your specific ear shape. Every time you put your AirPods in, that process happens automatically in the background, tuning the sound specifically for you without you doing anything. The speaker driver that sits behind the H2 chip is a custom-designed transducer that Apple engineered from scratch. A speaker driver works by vibrating a thin membrane called a diaphragm at precise frequencies to produce sound waves. In a full-size speaker, you have plenty of space to work with. In an AirPod, the driver diameter is just a few millimeters, and the diaphragm is so thin it is measured in micrometers, 1 micrometer being 1,000th of a millimeter. Manufacturing a diaphragm at this thickness with consistent properties across millions of units is extraordinarily difficult because at that scale, tiny variations in material thickness directly affect the frequency response of the driver. Apple uses a custom polymer material for the diaphragm, and the manufacturing process for it happens in a clean room environment where contamination control is as strict as you would find in semiconductor fabrication. Now, here is the part that most people find hard to believe. Each AirPod contains not one microphone, but multiple microphones, and they are used in a system called beamforming. Beamforming means that by analyzing the tiny differences in timing and level between what each microphone picks up, the chip can work out the direction that sounds are coming from. Sounds coming from in front of you, meaning your voice when you are on a call, get amplified and passed through. Sounds coming from other directions, meaning background noise, get cancelled. This is how AirPods manage to make your voice sound clear on calls, even when you are standing on a noisy street or sitting in a busy coffee shop. The processing that makes that work is happening on the H2 chip inside the AirPod itself in real time, with no help from your phone. The active noise cancellation system adds another layer on top of all of this. The outward-facing microphone on each AirPod listens to the sound in the environment around you and sends that information to the H2 chip, which analyzes the incoming sound wave and generates an equal and opposite sound wave through the speaker, cancelling the noise before it reaches your eardrum. This process happens in under 2 milliseconds. 2 milliseconds is so fast that by the time the sound wave from a passing car engine physically travels from the outer microphone to the position of your eardrum, the cancellation signal is already there waiting for it. Getting this timing right requires the H2 chip to know with extreme accuracy exactly how long it takes sound to travel the physical distance between the outer microphone and your ear canal. And because every ear is shaped differently, this distance varies between users. Apple calibrates the system to work within a range that covers the vast majority of human ear shapes, which required extensive acoustic measurement testing across thousands of different ear geometries during the development process. Back Back on the factory floor, once the H2 chip, the speaker driver, the microphones, the accelerometer, and the optical ear detection sensor are all placed and soldered onto the internal components, the antenna system gets installed. The Airpods antenna is not a visible component. It is printed directly onto the inside surface of the plastic shell using a process called laser direct structuring. A laser draws the antenna pattern directly onto the plastic, and then a chemical process deposits conductive material exactly where the laser traced, creating a fully functional antenna that is integrated into the shell itself with no physical antenna wire anywhere in the device. The shape and dimensions of this antenna determine the Bluetooth range and stability of the connection, so the laser structuring process has to reproduce the antenna geometry with extreme precision on every single unit. The ICE battery in each Airpod is a custom lithium-ion cell, so small that it makes a standard watch battery look large. Assembling a battery this small and connecting it to the power management circuitry inside the Airpod without damaging either component requires robotic assembly tools that operate under magnification and with force limits measured in millinewtons. 1 millinewton is approximately 1/10 of a gram of force. If the connection is made with too much force, the battery cell or the circuit board flexes slightly and a hairline fracture forms that will not cause a failure today but will cause an intermittent connection problem 6 months into the product's life. So the assembly robots are programmed to apply exactly the right force every single time, and every connection is verified by a sensor in the robot before the process proceeds to the next step. After assembly, every single Airpod goes through an acoustic test. It sits on a precision acoustic measurement rig where a calibrated reference microphone sits at a standardized ear canal distance, and the Airpod plays a sweep of test tones across its full frequency range. The frequency response of that specific unit gets compared against Apple's reference curve, and if any frequency is more than a small fraction of a decibel above or below the reference, the unit is flagged. Apple does not accept Airpods where one earbud sounds slightly different from the other. Left and right channel matching is tested on every pair, not on samples every pair, because if the left Airpod has even a subtle difference in its frequency response compared to the right one, the spatial audio and noise cancellation systems that depend on both ears receiving matched signals will not work correctly. The charging case goes through its own manufacturing process. The hinge mechanism on the lid of the Airpods case is machined from stainless steel to tolerances tight enough that the lid closes with the same satisfying snap every single time across a lifetime of openings and closings. The magnets that hold the Airpods in their seats inside the case are positioned with precision to ensure the charging contacts on the bottom of each Airpod align perfectly with the charging pins in the case every single time you drop them in, regardless of the angle you insert them at. And the wireless charging coil in the case is wound and positioned to work with any key-compatible charging pad, with enough positional tolerance that the case does not need to be placed on the charger with perfect precision to charge reliably. When every test is passed and every component is verified, the Airpods and their case get paired together permanently in software, packaged together and sealed. Apple has shipped over 600 million Airpods since they launched in 2016. Over 600 million individual pairs, each one built to this standard, each one tested individually before leaving the factory. That number is so large, it is hard to process. But what it tells you is that the manufacturing process Apple built for Airpods is not just precise. It is precise and repeatable at a scale that has never been done before in audio hardware. The engineering inside those two tiny white earbuds was never magic. It was always just extraordinary manufacturing, done better than anyone thought was possible, making something unbelievably complicated feel effortless. And that, more than anything else, is the real secret behind why Airpods changed the world. Now, if you want to see that how Apple Vision Pro or Apple Watch Ultra made it inside the factory, visit my channel or click on these videos to watch. I will meet you there.